Richard Boyd is an entrepreneur and expert in AI, machine learning, virtual worlds, computer gaming, and human-machine interfaces. So welcome, Richard. Please give your presentation.
Well, hello, everyone. Thank you for inviting me to join you at Reinforce AI this year. I wish I was there in person. I understand it's a lovely city, and I've not been there before, so I wish I was there, but I'm really excited to share some of the ideas that my team has been working on for the last 10 or so years here in the United States, and to hear your thoughts afterwards and to get into, I hope, will be a rich discussion about the future of these technologies. So, are we sharing the screen? Do we have liftoff? All right. The title of my talk, or what I want to talk about, is pretty broad. It's Life, the Metaverse, and Everything. So the Metaverse has been something that we've been talking about a lot here recently with Facebook beginning to focus on shared collaborative 3D environments. And I hope everyone gets this quote. If you're not familiar with it, life, the universe, and everything, of course, comes from my friend Douglas Adams, who I miss dearly, the science fiction writer of Hitchhiker's Guide to the Galaxy. But I will be talking about some of the ideas that he had as well, and weaving those into our discussion today. So this is a little bit about my background, just so you know what my perspective is. I think anytime we have these sorts of conference discussions, it's important to understand where someone's coming from, what is their background, why do they have the opinions that they do, and why are they working on and admiring the problems that they're admiring. So this is my background. I've worked in computer gaming for almost 30 years. So you can see some of that. This is what I call my street cred slide. It's everything on one slide, but my team and I have worked in the movie industry. We've worked on a number of different game companies. We did games with author Tom Clancy. We've done games, of course, with Douglas Adams, who I've mentioned, Starship Titanic, if any of you played that in the late 90s. We did game companies with Michael Crichton, even Ozzy Osbourne. And only one of those people is still alive, so I'll let you think about that for a second. Then I worked at Lockheed Martin, the big aerospace company that makes fighter jets and spaceships. But we worked there on, I created a group called Virtual World Labs, where we focused on artificial intelligence, augmented reality, virtual reality, and of course machine learning, which we're going to talk about a lot during the next 45 minutes, about how that is different, why machine learning absolutely changed everything for me beginning in 2009. So that's where I want to focus today. But first, just a nod to my friend Douglas Adams. I hope some of you have read his work. I even hope some of you played this game. But I'm taking you back to 1997. At the time, I was working with Douglas on this game, and what was unique about it was way back then, before the turn of the century, we started, AI was always part of gaming. If you're going to make convincing characters, convincing environments that people want to spend their game time in, you have to have artificial intelligence. But back then, it was pretty straightforward. But this new thing that we did in '97 is we actually had characters in the game you could talk to. So you could actually have conversations with them, and they would have reasonably good conversations back with you. In fact, sometimes the game characters would surprise us a little bit because there was a little bit of adaptive conversation in the AI. We called it velocitext, and Douglas actually called it spooky talk, because sometimes he would talk to one of the game characters and he would be surprised by the depth of their response. And that was just the beginning of when things started getting a little weird and interesting, and that's the journey I want to take you on here. But here's where I think we are in general. The thesis statement, I believe all of you should be thinking about if you aren't already. If you're at this conference, you're already thinking about it. But I believe the biggest problem or the biggest focus for this century, whether you're a government, a company, or even an individual, is you should be looking at everything you're doing and trying to understand what should we keep for human attention and human effort, and which things should we start turning over to machine attention, machine judgment, machine effort. And that balance, anyone who gets that balance right is going to succeed, is going to prosper. And I believe we're already at a point here in 2022 where if you're not doing this, you're increasingly at a disadvantage to the point where you may become irrelevant. So we need to talk about that. Just a little more framing. This is how I think about the entire information age. You know, in the beginning, it was about, if any of you play chess, I kind of map it the way I would a chess game. You have the opening game, you have the middle game, you have the end game. In the beginning, we were sort of building these technologies, trying to understand them. Like Marshall McLuhan said, the things that we were building were actually affecting us. They were making us. The things we make us. So we shape our tools, and then they have an effect on us. I like to think that in the last century, when we had major events like all the events we're having now with pandemics and invasions of Ukraine and all of this, that in the last century we would review it and think about it as humanity by reviewing video footage. This century, I believe, is different. This century is about prediction. It's about simulation and kind of looking into the future to understand the effects of what we're actually doing. But the middle game was, which I believe we're in right now, is where the machines are beginning to adapt to us. Instead of us having to learn how to do batch commands and getting carpal tunnel syndrome from using our mice and typing, the machines are starting to just, you can now walk into a room and say, "Hey Siri," or "Hey Alexa." Sorry, all my devices are lighting up now. And get what you need. So I believe that we're getting to a point where our machine technology shouldn't even need our finger to push a button anymore. They should just begin to understand what our intentions are, what our needs are, and bring those things to us before we actually even need them. And then where do we go in this end game? Well, we all need to talk about that. There's this idea that Vernor Vinge talked about. This is another science fiction writer. If you can't tell, I'm a science fiction fan, where he talked about the technological singularity. If there are any physics majors out there or PhDs, the idea in a black hole of a singularity is it's that point at which our technologies and capabilities don't let us see beyond that point. And the technological singularity, as Vernor Vinge and people like Ray Kurzweil talk about, is a point at which our technologies have evolved. Like the things we've made have gotten out of our control, which they already are, I believe. They're so complex, we don't even understand how they work, much less can we control them. And once we get to a point, as Kurzweil says, will happen in just a few years here, where $1,000 of technology, of computing power, is more powerful than the human brain, and it can adapt itself and improve itself. That's the last invention we'll ever make. And it's hard for us to make any plans or understand what's going to happen after that. So put a pin in that, and we'll talk about it at the end of this conversation. But of course, all of this is being driven by Moore's Law. Moore's Law says, well, Moore's Law and Metcalfe's Law, but Moore's Law says that the sort of price performance of compute power doubles roughly every 18 months. And people for a long time have thought that that's going to end soon, but we don't see any signs of it stopping. It may mean that we have to switch from silicon to some other medium, like quantum computing or some other capabilities, but it is happening. So here's just a quick sort of review of or a visualization of Moore's Law at work from my perspective. I mentioned that I worked in the movie industry. We've done a lot of work with the director James Cameron. If you guys have seen movies like Avatar, of course, and The Abyss and other movies like that. This is me on the set of Avatar in 2009, and Jim is there showing me the camera that he was using at the time to do stereoscopic 3D. It's this massive piece of equipment. He actually invented it. And that's me there with Vince Pace, who's the co-inventor of it. And you can see the size of it. But what you see in the lower left-hand corner is the camera he's using on the next 3 movies. So one of the things that happens with Moore's Law is it really shrinks the size of the tech we have. So now we have supercomputers in our hands today. I mean, all of us have these things today. But that's just one piece of it. It's also the acceleration of the processing that we can use to do things like machine learning, like we'll talk about next. So I've talked about what the key to the century is. Now I want to give you some application areas, like places where it's already being used to great effect, and some areas like at the end here that I hope is on all of our minds is how do we bend all of this technology towards good, towards benevolence, so that we're really trying to solve not just for more efficient work or even just better decisions, but also for better societal outcomes, more wellness, that sort of thing. One of the things that's troubled me deeply over the last 2 decades is, I've worked with people like, I've had investments from people like Reid Hoffman, who created LinkedIn, and a lot of these folks who are working in social media. So we have a lot of powerful technology, and unfortunately we've used a lot of it just to create a mirror so we can all look at ourselves or take pictures of our food, and we've seen some of the positive, but also some very negative effects of that. What I'm interested in doing, and I hope all of you are interested in doing, is taking this technology and thinking about how do we cure cancer, how do we end war, how do we populate the stars, and do things that I believe will create better societal outcomes for all of us. So that's what we're going to talk about. So another quick little story. Again in 2009, I hope you can see that in 2009 that had a big seismic effect on my career. I was already at Lockheed. I was working on all these patents on AI and VR and AR and machine learning, but I didn't learn about machine learning until that year. And I knew that it existed, but I didn't realize how powerful it was. So this is a picture of me at Microsoft Research Labs in San Francisco, working with Alex Kipman and Jaron Lanier. Jaron, if you don't know him, he's the guy who came up with the term virtual reality. So a lot of icons in the industry. But they were working on this project to try to get a controller for the Microsoft Xbox that could understand everything that was in a living room and could recognize you when you walk into the room and let your body and your gestures become the controller. So it's the beginning of that sort of ambient use of technology that I talk about. And that's why I always say 2009 is the time when a lot of things changed. And at that time, it took 124,000 hours of compute time just to teach this system what a living room is. What's the difference between a table and a lamp and a chair and a cat and a dog, and of course to recognize me and my movements. We've come a long time since then, but that really remapped my brain, is this idea that the old AI or old artificial intelligence was, first a human had to understand something like how do I drive a car, and then I would have to sit down and write the code into the computer to tell the computer, here's how you drive a car. Now the problem with that is we don't really understand how humans drive cars, right? So how do you tell a computer how to do it? But machine learning, the new way is, instead of creating algorithms, you have large data sets of examples, like video of people driving cars all over the world, and actually let the machine look at all those examples, infer its own understanding, and create its own adaptive algorithms, I suppose, to learn how a machine should drive a car with LiDAR and with GPS and with other things that we humans actually don't have when we drive. So this was an earth-shattering sort of moment for me, and that sort of informed everything I've done since then. So again, I've talked about these three phases. Now let's begin to talk about where we go from there. And we only have 45 minutes. If I had 2 or 3 hours, I would go through everything that I've been doing in the last 10 years. Like, one of the things I did is we taught one of our machine learning systems how to actually do legal work. So we fed it every single legal opinion in United States history, over 4 million different legal opinions, everything since 1797, and we have this little artificial intelligence lawyer at our disposal. And I think that kind of that kind of automation is really fascinating and really useful. And we've done the same thing in accounting, for example. We built a system 4 years ago, or almost 5 years ago now, that could audit a business. So it can go through and read absolutely everything, begin to perform the audit letter, and actually write the audit letter before a human even gets involved. And that's happened many years ago. So this is all happening very fast. But now let's talk about where I think we are now, and I believe that sort of happened in 2018, as we've gone beyond just data scientists to wrangle data together so we can train these systems, and now we're starting to think about how do we understand human behavior. That's never been more important than in the last two years or so with the pandemic. It's like, how do we understand human behavior, how people are reacting and feeling about things, and how do we talk about how to use these technologies to educate and encourage people towards better behavior. So one of the things I created with some of these scientists you see in the picture there, Dr. Richard Carson from UCal San Diego, Dr. Jordan Louvier, who's in the state of Washington now, and Kevin Clark is standing next to me. He was with IBM. We use this capability of taking large data sets to train machine learning systems and realize that we don't need to just use them to automate work and automate efficient systems, but also we can understand humans. Like, we almost made a dating product. So we had our system crawl over 3 million OkCupid profiles, and it actually made these little data models of all the people on OkCupid on this dating site, and this was 7 years ago. And then all we had to figure out is, how do you actually, what are the best matches of people, physical characteristics and interests and personalities? And that was a pretty straightforward machine learning application. I'm sure it's being used deeply in dating apps today. Thankfully, I don't have to use them right now, but I decided not to do that. But I think there's some other interesting things we can do with it. Now, I mentioned I was at Lockheed Martin, and while I was there, we were using these agent-based big simulation capabilities. So if I wanted to understand, what the people of Haiti were doing or how they were feeling after an earthquake, or if I wanted to go in and model Afghanistan, because I've got some USAID workers who are coming in who want to build bridges and dig wells and do things, we wouldn't create these, and these are just like game characters from my game days in the 90s and 2000s. We wouldn't just have like 3 or 4 people and say like, well, there's 5 or 6 main types of people in Afghanistan. You have your Sunnis, your Shias, your Coptic Christians, your UN workers or whatever. We would have thousands of agent-based models of people with their values, their traditions, how they feel about different subjects. We'd put them into these simulations and say, if we go in here and build a school for girls in Helmand Province, show me all the people in this area who are going to feel good about this. They're going to be green. In gaming terms, I would say their faction reputation, our faction reputation with them is high because they like the fact we're building a school for girls. And then you might have a lot of people who are sort of neutral on it or on the fence, but then it would also reveal those who are really angry about it, who might decide to burn down the school or shoot Malala, right? So we'd run these simulations first before we would do anything, and that's why I call this the simulation century, because this is incredibly important. Model it, simulate it, use AI, but these were still pretty simple agent-based models back then. But now I have this new power. Remember, I have machine learning today where I don't have to sit down and program a game character or the model of a person in Afghanistan or Haiti or Vladimir Putin. Instead, what I can do is take large amounts of data. So we started experimenting years ago with like taking people from history. So I could take everything Victor Hugo's ever written, everything written about him, that's available on the internet, like thousands and thousands of documents and text in different languages, feed it into my machine learning system, and it immediately created that sort of very similar to what we did in the dating application. We now have a model of Victor Hugo that has a sentiment model, it's got an interest graph, it's got even a small behavior tree if I've got behaviors for him. And the first thing we did is just released him on the internet and said, what does Victor Hugo think about modern life? And he can actually read articles, watch YouTube videos, listen to podcasts, and he scores them. I don't know if you can see on the screen, but he gives little scores to everything he sees and hears. He's got a little interest cloud there. It also tells me what sources are most interesting to him. Initially, I called this the empathy engine because it lets me see the world through Victor Hugo's eyes, even though he doesn't exist anymore. And anybody who I have a lot of data for, I can do this. I can do this for George Washington, Martin Luther King, Vladimir Putin, if I wanted to. And we have. We'll get to that in a second. But think about how you can use this for good. So if I'm in government, I'm a governor of a state, or this is a local town here in North Carolina where I live. And if you want to and I'm using fictional characters here once again, but if you're in government and you truly want to understand what do the people in Budapest feel right now? What are they thinking about what's happening in the Ukraine and about the pandemic and about the financial circumstances they're in and social policies? In this case, what I'm showing is this idea of an extra tax. We want to levy a tax on the people, but we're trying to explain why it's a good thing and why they should support it. And I can see from each one of these groups of people how they feel about it and what's their position from their perspective. And that's really important because now I know from this, I need to go focus on this group over here and try to explain to them a little bit better, communicate why this is beneficial and why they should support it. So and of course we've used it also in marketing. So what you're seeing here is the Procter & Gamble and the market research sort of application of this technology, where, if I'm Coca-Cola or if I'm Nabisco or Xerox, and I want to understand who my customers are and what they think about my product. I'm the president of Coca-Cola. I wake up and I want to see, how do people feel about my product today? Who's moving away from me towards Pepsi and who's coming back towards me towards Coca-Cola? What kinds of advertising or words and messaging and narrative can I employ? And what you're seeing there is real-time reactions from groups of people to text. And if I go in and make changes to that text, their reactions will update in real time with how they feel and think about the thing that I'm writing. So this now gives me a new tool for how I communicate about my product. So there's a good, for those of you who are focused on money-making applications, this completely revolutionizes market research, where old market research was go out and do surveys, ask people questions on the street, and try to get their results in writing, and then come back and try to design an ad campaign or a new product. The problem with that is people don't always tell the truth. They manipulate it. Even when they're trying to tell the truth, there's a whole book out there that's called Everybody Lies in Market Research that talks about this, and Netflix has learned this. If you want to understand people, you don't ask them questions or polls. You watch what they do with their money and with their attention online. So, focus groups and surveys didn't predict Donald Trump. They didn't predict Brexit. What did is watching Google search data, Amazon purchase data, that sort of thing. So that data is now available, and we can use it to model people and understand them. And then the next thing is about how do we actually use that information to convince people towards different behavior. And of course, that can, like every technology, can be used for good or for not so good things. Here's an example. I spoke at a Comic-Con. We have this thing in the U.S. called Comic-Con, where people dress up like they're, Batman and, their favorite comic book characters or from TV, and have these big conferences. Stan Lee had just died recently, and I used this capability to model him, and I let the audience now actually ask him questions. So they could ask him questions live, and he would respond to them. Who would win in a fight between Hulk and Thor? And if he's ever answered that question before, this system could interpret his past responses and give an answer. So you can actually talk to him. And if I've got data about things that he did, transaction data about where he shopped, what he did, like from his bank or whatever, I'm just showing what's possible here. Then I can actually tell you, well, if Stan Lee was in Budapest right now at this conference, he would likely be doing these following things based on the model of him. And of course, I had some coverage, some of you may have seen this, where my father died in 2017. And it only took me a few days before I realized I was still in mourning, but I realized I have to do this for my dad. And I made a model of him, and I'm still able to visit and talk to him every day. The problem with him is he didn't have a massive Google footprint. He wasn't on social media, right? So I had to hand construct a lot of what his model was, and I actually had to have my system read, I had to scan in all of his personal letters, his military records, things like that, to make this model of him. So really, is it him, or is it really just my conception of who I thought he was? In the end, all that matters to me is that it's comforting to still be able to visit my father and talk to him, even though he's been gone for 5 years. I'm sure we'll talk about that when we get to the conversation at the end. But let's talk about some positive applications. So my team also applied for this thing called the X Prize. For those of you who don't know it, there are these prizes that come out of the West Coast here in the United States around ideas like, how do you build a 50-year battery? How do we populate Mars? SpaceX and all that stuff came from initial sort of X Prize challenges where you get a bunch of teams compete and you get like $1 million for winning it. We competed on this pandemic response challenge. Like, how do you use AI and machine learning to capture all the data out there and really try to predict like what's going to happen in every community around, in our case, it was around the United States, and which interventions, which investments and policies, county by county, for all 3,100 counties, whatever it is, can we employ, and how are people going to feel and act and think about that, and which actions will get the best behavior? So I don't have time to go through this whole simulation for you, but the idea here on the left is we have competing narratives, right? Like probably everywhere in the world, there were narratives saying, let's just go for herd immunity. Let's I don't need to wear a mask. That's too much, government oversight. I don't want a social distance. I don't want you to hinder my ability to go out and move about my city. And the other one was, no, let's try to hunker down, be safe, listen to the authorities, and wear masks and social distance, and let's see if we can't, knock this thing out very quickly. So we had competing narratives, and what this shows is the top 10 groups in the left-hand side in this community, and I can see how they're moving towards the different narrative positions. Now, if I was showing you this live, I would show you that there are influencers. So I can figure out who the influencers are, what the messages are, and look at this campaign over time and figure out which words said by what people can actually move people to the behavior that I want. And it's different for every one of these groups. Some people, like if I have Oprah say it, it's going to affect a lot more people in this area, and I can actually watch them move towards the position I want, where they're moving less, and that's what you see on the right-hand side is movement probability, activity probability, how that translates in the upper right-hand side to ICU beds, death rates, all sorts of things, and that's what you're seeing in the middle is sort of the game of life transaction or transmission of the virus based on the activity that's happening in every single community. So we were a finalist for that with this technology. We didn't finish it because we were too busy to do the final data set. But you can go to places like smartwa.us here and see our dashboard for the state of Washington here in the United States, where you have little simulators where county by county I can say, well, I run a delicatessen, or I run a gym, or I have a movie theater. Tell me what's happening in my community. How are people feeling and thinking? Which policies can I adopt for my business, and how is that likely to affect what I do? What happens in my community? Am I going to get more customers, less customers? So you can actually translate it to economic benefit as well as better public health. And I'll just leave that there because, again, that's a deep idea. But this idea of narratives and information warfare is something I'm thinking about a lot. You can see me, this is me speaking in 2016 about what happened at that time here in the United States when Russia first started getting involved in our narratives and the power of that. And at the time, I was meeting with officials in the Pentagon, and you can see some of the folks there, Rand Corporation, and we were talking about, what should we be doing? And everyone says, look, we're the United States. We're not going to be involved in propaganda. We're uncomfortable with that. And of course, the study that we came up with recognized the fact that we can't afford to just let one side of narratives come through, right? We have to be able to combat it with counter narratives and what we believe is true and right. Of course, again, this can be used for ill, it can be used for good. But I did a tour around that time also, just before that, of the country of Italy. So I spoke in 4 different universities there, from Bari to Venice to Rome and Florence. And I was asking people in Italy how they felt about the 2014 deposing of the president at that time. And I just asked them a simple question: was that was that an internal revolution, or was that a Western, sort of influence coup? And the majority of the people there said that it was a Western coup, but it's okay, and here's why. I'm like, well, that's not our narrative at all. We believe it was an actual uprising of the people in Ukraine to throw out this Russian puppet. That's what they wanted to do. But that narrative wasn't present. And when I asked people, where are you getting your information? Who are your influencers? Who are your top sources? It turned out to be Russian-sponsored television all across Italy. And so they were only getting one side of the narrative. So it's important that we do use these technologies in these narratives. All right, just let's switch over now to something a little more benevolent and thoughtful. How about this idea of using machine learning to monitor your own health? So this idea, I'm really interested in each of us being able to take control of our own health, use these powers of modeling and simulating. So I could model and simulate every single health intervention I've ever had in my life, my family history, my genealogical data, everything that's ever happened to me, and then take that and be able to sort of Tamagotchi-like, if you guys are gamers and understand that concept, of look into the future and think, what things can I do about diet, exercise, and whatever that would extend my life and the trajectory of my health such that I can still ski at 70, I'm going to be able to meet my grandchildren, that kind of thing. So this is another important idea that I'm really interested in exploring, and we're doing that also with some CARES Act grants that came out of the pandemic in the United States. But this is like, imagine having a 3D model of your body with, the time you had ACL surgery or your appendix out or whatever, and then being able to use a prediction engine to look out and see, like, what's unique to you and where you live and your body and your history that gives you the outcomes that you're looking for. And we're also looking at that for soldiers here in the U.S. The old idea of training soldiers was, how many push-ups can they do? What kind of marksmanship skills do they have? And how do I move them, physical capability and skills-wise, through basic training, and then beyond to their career in the Army. Well, now we're looking at it a little more thoughtfully and realizing that there's more dimensions to performance and to better outcomes and better teams of people working together than just skills and training and physical capability. What about emotional state, or what's going on in that person's personal life? How are they doing financially? What are their relationships like? How do they fit into the culture of this unit? And maybe we need to move people around to build better cultural groups of people. I'm just laying the foundation for that so we can think about other ideas. But this is a program we're working on now. I won't spend too much time talking about it. But again, this idea of like focusing on people and wellness and performance is something that's one of the problems my team is admiring. So this same idea think about a company. So whether you're IBM or Google or Apple or a small company somewhere, managing your people and leading people is more than just what skills and experience do people have, and are they performing their job or not. If you really want high performing organizations, and again, map this back to even governing the people of Budapest, if you had a model like this of how are they doing, how are they feeling, what's unique about these people, can we get data about the community and how they're feeling physically, emotionally? Are they under stress? How are they doing financially? Do they feel like they're part of the community or part of the company? And what interventions does the system recommend that I can do to try to bridge some of those gaps, especially if I map these people up against something like a pandemic or war, or hopefully not, or economic downturns or whatever. Who needs what kind of help in what order is a way to put it. And just so you know, like folks like the Internal Revenue Service, where we pay our taxes here in the United States, they recently put out a request for information for a program where they want to build not just Sim City, but Sim Country, and have data on all of us. And do they have the data? Yes. Location services, health data, bank data, all of it's there. So we can build really rich, deep models of people, put them into simulations, and try to guide them. And again, hopefully, that's what I keep hoping for, is hopefully towards benevolent outcomes. One more thought here is I'm still thinking about this idea of community wellness. We're working with folks like ShareCare here in the United States around like modeling communities, looking at that data, understanding people in need, what needs do people have, and then again, looking into the future, using AI, machine learning, and modeling to try to imagine the outcome we want, where everybody, when you walk down the street, everybody's happy, everybody feels a sense of belonging, everybody feels like their main needs are being filled, they're climbing up Maslow's hierarchy of needs, and we have this, I'm not saying complete utopia, but why not take these powerful technologies and bend them towards that? And if we bend them towards that, instead of making things blow up and towards warfare, I believe that we're going to have a much better century than the one we're contemplating right now. So that's my thoughts for today. I really do think there's an opportunity to use technologies not just to make work more efficient, not even just, and I really do think technologies are going to be really good for improving judgment and improving information work. But I like the idea of education, healthcare, competing against the disinformation and bad narratives that are out there. That these technologies can help with that. And how about solving for better communities, better cities, better populations of people, better understanding between countries and between different ethnic groups around the world? I think that is the utility function I would like to solve for, and I'm really interested in hearing what all of you think about this. Here's some additional reading and ways to contact me if you want to complain or carry on the conversation after this. Those are my comments for the day. Again, I wish I was there with you in your beautiful city, but hopefully I will be there soon, and I look forward to the conversation.
Hey, thank you very much, Richard, for the presentation. And I think you haven't seen this one. This is a small gift from the conference to you. It's super.
Oh, thank you. Oh, great.
I see you're smiling, so probably your well-being is okay, according to the picture. Maybe an AI can tell that as well. Thank you.
Oh, it looks lovely. Yeah, and if I could, yeah, if you just take a picture of it, we'll turn it into an NFT and the unique token of it.
Good. You will get it on the post.
Wonderful. Thank you.
And thank you very much once again for the wonderful presentation. I would like to call the audience for the questions and answers session. And I see that you have already put some of the questions and answers there. So you see the chat, the polls, and the question and answer. In the polls, you can rate the presentation. And in the question and answer, you can like the questions. So I will always read the most liked questions there. And the first question, therefore, I will read is one from Jeffrey Westling. In social distancing simulation example about understanding the user's feeling about an action, what is the data being used? Or rather, in real-world use case for a business, synthetic or actual user data?
Yeah, so modeling humans is a complex activity because we humans are complex. And the modeling, that I did have a chart on that. I had to take it out so I'd have enough time to go through everything with you folks. But the way we do it is we have this sort of data fusion model where you start with basic data, like demographic data. And here in the U.S., it's reasonably easy to get that. You can get it from public health surveys and sort of things like that. And then what you want to do, like I said, if you want to understand people, demographic information is not enough. What you want is their activity. You want to know what they're doing with their money and with their time. And once you understand their attention, that is who people really are. Like I mentioned that book, Information Lies, or Everybody Lies. I had it on my screen at the end there. You don't have to read the whole book, but I'll sum it up for you. What it says is, we humans are poor witnesses to our own narratives. What that means is, like I said, even when we try to tell the truth, if I ask you, how many glasses of wine do you have a week? How much do you ever smoke cigarettes? How often do you exercise? You might answer and think you're telling the truth, and then what I'll do is say, well, thank you for that answer. Now let's see what the data says. Let's look at what you did with your grocery, rewards card. And location services. By the way, if you've got location services on your phone, I get a rich data set from that, and it's really easy to get it. That shows where you go during the day, how much time you spend at each place, and I don't need it to be individually identifiable of you. What we end up doing is modeling groups of people. Now, I mentioned my example of when we were modeling Afghanistan, we have thousands of agent-based models. When I first left Lockheed and started looking at, what's happening in market research in the United States, where we spend $3 billion a year doing focus groups and surveys, people would, like even I won't mention any companies by name, but big, huge consumer brands or folks selling computers. I'll talk about this. One computer company had spent $1.5 million trying to model who their customers were, and in the end, they ended up with 8 what they call segmentation models. There's iPhone Mom, there's Joey Gearhead, there's, they have these names for people. And I looked at that and I said, really, are there only 8 ways to buy a computer? Why don't you have 127 million? Because that's how many households we have in the United States. The technologies I have today will let me give you a model for every household in the United States. I can tell you the body mass index of every house in the United States. But it turns out that's not helpful or necessary. We did another project with a chicken company, and I said the same thing before I really understood it, where I said, why don't we have 120? I can make a simulation of everybody in the United States and how each of them goes about buying chicken. But and at the time, they had about 5 or 6 models, like here are chicken buyers, organic chicken, this kind of chicken. what we ended up doing, though, is using the machine learning to figure out what are the top meaningful ways to buy chicken. Turns out, and we ended up just cutting it off at 42. There's 42 ways to think about and behave around buying chicken. And now the exercise is draw, a circle around the state of New York and say how many of those 42 types are there, how many people are in each category, and that governs what you need to do around what products are on the shelf, what your pricing needs to be, packaging, your messaging, your advertising, and that's the exercise. So it's demographic data, it's public health data, and then you keep fusing in. If you get location services, the best data is bank data. And I'll just let you think about that. You can't lie to your bank. You can't say, well, I'm sorry I didn't send my payment in. I was traveling in Cancun last week. They'll say, no, you weren't. I know exactly where you were. I can see where you got gas and what you did, and I see these patterns of behavior, and they have deep models of all of us. So the genie's already out of the bottle, but it's about your transactional data. And we do things like get data from Nielsen and et cetera. I know this is a long-winded answer, but it's a complex activity, but it never ends. That data fusion process is a new thing that just never ends.
Thank you very much, Richard. I hope, Jeffrey, you got your answer, but I would like to encourage everyone that in the break, there's a networking session, so if Richard is available and if you could join the networking, then you can chat about it as well. Let's take the next question. The next question is coming from Peter Silvasi. He's mentioning, you mentioned that creating people as an AI model called personas. What was your first feelings when you talked to your father?
Yeah, it was, a lot of people have asked me that question. I ended up doing a tour of South America to places like Buenos Aires and Medellin, Colombia, where I'll just say that the cultures in South America really love this idea of being able to talk to their ancestors and get opinions. So I did a lot of interviews, and you saw some of those listed there, and I'll share all these out afterwards. But yeah, I mean, my reaction is that it was oddly comforting. And I know some people get kind of squeamish about, like, how could that have even been helpful, or, do I want that even? And I'll just say, in my case, it was comforting to be able to commune with that model of him. And again, I totally understand it's not him. It's the shadow model of him. But the fact that, as the years go by, it's on his birthday, it's 4th of July or whatever, or anytime, I can just go visit him and see, like, what does he think? And, my father and I had some disagreements about life. We didn't agree politically, for example. And there's certain issues we just didn't agree on. And I still find myself almost wanting to argue with him when I see him say, oh, this thing happened, and I feel really strongly that was the right thing. And I'm going, no, Dad, I feel that's the wrong thing. So I have those kinds of reactions, and then I have to pause for a minute and go, oh yeah, he's not actually really available to me to talk to him. But oddly comforting is my answer, it was a helpful activity. But imagine, when I was in South America, there were a lot of people came to me and said, every time I have a major life decision, I pray to my grandmother, my grandfather, my uncle, whoever, and what if you could really do that with this? Should I take this job? Should I get married? Should I move to this city? And you can go just like I did with that school bond referendum, and I could say, what would the people I cared about who are no longer here, what would they think about my decision, and what's their guidance? But if you didn't want to do your family, what if you just wanted to bring in Leonardo da Vinci and Victor Hugo and all the people that you see that I've modeled there, and get their different opinions, because they do differ, right, on a major life decision, just so you're getting some other perspective.
So let's take yet another question, and that one would come from Zsolt Baracsi. When you are teaching artificial intelligence like a Stanley persona, are you concerned with the data input from a morality angle, like how to avoid teaching them a bad behavior, bad language?
Always. I mean, that is the biggest issue with, the first thought of any data scientist who's doing this kind of work or this kind of exercise is give me all of the data without any regard for its source or how accurate it was, whatever. I want as much as I can. If you can give me, like I used the example of the millions of legal opinions from U.S. history, those are the data sets we get excited about. Or if I'm trying to train an automated vehicle, I want every single possible thing that a vehicle might encounter around the world so that I can train it on all those examples. But being able to screen those data sets first, that is its own sort of exercise. And by the way, we've been doing that in the Department of Defense here in the U.S. for a while. It's called V&V, validation and verification. So before you train a model of Vladimir Putin, and you're taking a whole bunch of intelligence data in to model who he is and what he's likely to do, you want to make sure that every single source is accurate, is authentic, and that's difficult to do. So that's its own exercise. And thankfully, what's happening over the last 4 or 5 years is that there are organizations who are collecting that data and doing that validation and verification. And there are ways also to try to screen for bias in the data. But sometimes it's just because of the nature of it, especially historic data from legal systems, it's already built in. If your legal data is coming from, the 60s and the 50s in the United States, well, it's already racially charged and weighted in one direction, and you've got to figure out how to solve for that. But if you're aware of it, at least you can compensate for it in the algorithm and override it a little bit. But that is a constant concern and probably the main concern. So thank you for that question.
Yes. Thank you for the questions. Actually, there are a couple of more questions, but we don't have time to discuss them right now. But I would like to encourage to take part on the networking session. And also, Richard, if you could take a look at the question, I think everybody will appreciate that you could write just a small reply then. So thank you very much once again for your presence and for the very interesting presentation. We will have a small break, networking session now, and we'll continue at 3 p.m. Central European time, so at the full hour. Thank you very much.
Outstanding. Thank you very much. I look forward to the continuing conversation.